Right guys, so this video is all about not necessarily solving trig problems, but because in C3 it can get quite complicated, identifying which method to use to solve trig equations, complex trig equations. So this is C3, so we're talking about R method, we're talking about double angle formula, we're talking about the factor formula, the addition formula, yeah? All these things, it's quite hard to recognize what it is that we need to use, which method, and it's okay not to be able to recognize, but just don't freak out. Just try a method, and if it doesn't give you the right method, if it doesn't give you what you expect, then you have other methods to draw on. So let's take this question one at a time. I've got this, and I've got this. Alright, so looking at this, if I'm familiar with my factor formula, then I can see that they kind of look like, if I times this thing by a half, and I have 2 sine 3x cos 2x equals a half, so I'm not timing it by a half, sorry, I'm taking a factor of a half out, right? These look very much like the factor formula. If I look at this first one, and I look at sine p plus sine q, this is the same as 2 sine p plus q over 2, remember, from our factor formula, cos p minus q over 2. Okay? And so does this one. This one looks in the same form as well. So if we take number 1 first, I'll call this not number 2, if we take number 1, this 3x here, my 3x here must equal p plus q over 2, which gives me 6x equals p plus q, so that's equation 1. This 2x must be my p minus q over 2, so therefore times that by 2, 4x equals p minus q, so that's number 2. So if I plus them together, I get 10x equals 2p, the q's disappear, implies p equals 5x. If I minus them, 6 minus 4 gives me 2x, p's disappear, q minus minus q is 2q, implies q gives me x. Right? So what about our number 2? Well, this time I've got 2x equals p plus q over 2 from here, going into this, which gives me 4x equals p plus q. And then this 3x gives me my p minus q over 2, which gives me 6x equals p minus q, so I've just times it by 2. So if I plus these together, I get 10x equals 2p as before, so I get p equals 5x. And if I minus them though, I get 4x minus 6x, which gives me minus 2x this time. P minus p disappears, q minus minus q gives me gives me 2q. So therefore q equals minus x in this case. So if I plug these back in for my number 1, this thing equals a half sine p plus sine q, where sine, so remember here, yep, so this is a half times that thing. Remember here my p is 5x, so 5x, plus sine my q is x, so sine x, equals a half. Here I've got sine p plus sine q, so sine p is 5x, plus sine of my q, which is minus x. So this is a half sine 5x plus a half sine x equals a half sine 5x, just multiplying out the bracket. But we need to recognize that sine minus x is minus sine x, isn't it? It's an odd function, so I get minus a half sine x. Bring them all over to the left hand side, this will cancel, and I get half sine x This is a minus here, so plus a half sine x equals 0 implies sine x, put them both together, equals 0. Then I can solve using cast. So x to the minus 1, x equals sine to the minus 1, 0 equals blah blah blah, your cast method, okay, between that given range in radians. The important bit was recognizing this method here. So that's quite hard, but recognizing the shape or the form it's in really helps me. Now what I've got is this, another scenario, root 3 sine 2x plus 2 sine squared x. So this is not easy and it's not obvious at all. But what you find is, well, in fact, let's do it. You would expect, probably in your mind, you're thinking, oh, I could use a double angle formula here because it's got sine 2x, I've got my theta the same, my x is the same, so I could easily put this in terms of x. So okay, let's try that, because root 3 sine 2x sine, this is root 3 times, remember sine 2x is 2 sine x cos x, yeah, plus 2 sine squared x equals 1. Okay, I could take a factor of sine x of 2 sine x out, so that gives me root 3 cos x plus 1 equals 1, equals 1, that's a pain, and if I put the 1 back in, there's nothing really I can do with that. I need it to equal 0 really if I'm going to have two factors, so no, this isn't quite the right method. Not to worry, maybe we can do something else with this. I think we can. Maybe we can recognize that 2 sine squared x looks kind of like it's involved in something else we know. If we look at cos 2x, we know this is the same as 1 minus 2 sine squared x. Yeah? So here, if I rewrite this as root 3 sine 2x plus 2 sine squared x minus 1 equals 0, take the minus sign out, so this is 1 minus 2 sine squared x equals 0. I can kind of see that this is cos 2x in here, isn't it? So actually what I have is I have root 3 sine 2x minus cos 2x equals 0. And now we've got a situation where our thetas are the same. I have just a cos and a sine, and I've got a constant next to each one, so obviously the constant is 1. So this means I use the R method, don't I? So let's do that. So if I say let R sine, remember I haven't got x this time, R sine 2x, I've got a minus sign here, so minus alpha equal this thing, root 3 sine 2x minus cos 2x, which equals 0. And if I expand this one to get r sine 2x cos theta minus r cos 2x sine, sorry not theta, alpha, and I make this here, I can compare my coefficients of sine and cos 2x. So I can say that r cos alpha is the same as root 3, and I can say that r sine alpha is the same as 1. So if I do r sine alpha over r cos alpha, this gives me tan alpha, which is the same as 1 divided by root 3. From my special triangles, don't need a calculator. Yeah. 1360 degrees, except we're working in pi, so I'll convert that into pi in a second. If I have 1 over root 3, this is 30 degrees, which means that alpha is pi over 6 radians. Yeah? So I've found my alpha, but now I need to find my r. So if I use my triangle knowledge, I should know that r squared equals root 3 squared plus 1 squared, because remember, cos from r cos alpha, sorry, I can say cos alpha equals root 3 over r. So if I drew that as a triangle, that's alpha. It's adjacent over hypotenuse, and similarly sine alpha equals 1 over r. So that means our opposite is 1. From Pythagoras, I can work out what r is. So I get r squared equals 3 plus 1, which is 4. So r equals 2. Yeah? Because normally it would express in the constant in the equation that r is a positive constant. And then from there I can finally rewrite this original problem here as r, which is 2, sine 2x minus our alpha is pi over 6 equals 0 with it between our range. And then I can start solving as normal using my cast. Time for one more, I think. So here I've got a sine x plus 40 plus sine x plus 50. So to me this looks like a factor formula problem because straight away I can see that I've got a sine p plus another sine q, because remember, if we've got a sine plus sine, or a cos plus cos, or a sine minus sine, or a cos minus cos, I can use the factor formula. Alright? So this then would give me, if I put it into the factor formula, because sine p plus sine q is the same as 2 sine p plus q over 2 cos p minus q over 2. So therefore I can say that this is in the form 2 sine, well, p is x plus 40 plus q is x plus 50, so that's 2x plus 90 over 2 cos p minus q, so x plus 40 minus x plus 50 is, the x's disappear, 40 minus 50 is minus 10 over 2 equals 0. Implies then that I have 2 sine x plus 45 degrees times cos of a negative angle, doesn't matter, it's still positive, so cos 5 degrees equals 0. So therefore this is just a number, isn't it? And this is just a number. So I actually have sine x plus 45 degrees equals 0, because if I divide both sides by 2, 0 divided by 2 is still 0, and 0 divided by cos 5 degrees, which is just a number, will give me 0. And now I can solve as normal using cast and my transformation. So I'll change the range. So if I do that, PV, I've got about a minute left. PV, x plus 45 degrees equals sine to the minus 1 of 0, which will probably give you 0. Range, I don't have 360 degrees and 0 anymore, I've got x plus 45, so 45 degrees, x plus 45 degrees, and 360 plus 45 is 405 degrees. Cast, well, I don't really need cast, because I know that sine crosses at 0, 180, 360, yeah, so x plus 45 degrees equals 0, but that's out of range. 180, 360, nothing else falls in my range, does it? So therefore x equals 135 degrees and 315 degrees. And we're done. I'll do some more in another video.